Alex Woody from HPC Wire here at the show floor at SC25. There's been a lot going on here the last few days. The HPC vendors have been showing off their new platforms. Quantum vendors have been coming on strong, and AI obviously seems to be everywhere. But let's hear what the attendees...
You want me to say my name and all that?
Do I just go?
What are we talking about?
No, what am I doing? What am I supposed to say?
Like this?
Oh, do we need a sound check? Knickers, 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 knickers.
We'll have to do a couple takes.
Oh God, sorry.
Okay.
Sorry.
Knickers.
I'll just say something and see how it works.
Okay.
Okay.
No, you're supposed to do three. You're supposed to count down. Hi, HPCers and supercomputing aficionados.
Welcome to SC25.
Everyone is here to talk about supercomputing. What I find really exciting is about supercomputing as a foundation for science. I really like seeing creative minds working together to think about ways to advance science in the service of society.
We are building an infrastructure for weather-driven AI models together with our member states so that we can more accurately predict extreme weather events, save lives, save properties, and just make the world a better place.
If you think of all of the diseases and grand challenges around health in the US, but also around the world, to really get to insights and find patterns and discoveries that then can improve health conditions for everyone, that really requires high-performance computing, and now augmented by AI. Not to replace traditional modeling and simulation, but to actually enhance and speed the time to discovery.
I'm extremely excited about what AI brings to the world. I think AI is really democratizing the way we're looking at information across industries, whether it's healthcare, energy, education, name it. You know, there's no industry that is not transforming with AI.
The number of students and number of faculty at Illinois has blossomed, mostly relative to AI and quantum. We have now doubled the CS department faculty, almost all of which are focused on AI. That's been probably the biggest change that I've seen in the last couple of years for how our institution actually is reacting.
We have had 24% of our 35,000 undergrads take at least one course where they actually had digital assets in the classroom, where the classroom meant Jupyter notebooks, where they did simulations, programming, they used AI and did all kinds of things that were totally inconceivable prior. With this new wave of digital assets in the classroom, the students are back to experiencing education. They're actually doing things, they're playing with things, they're learning by doing, not learning by listening to some old guy talking in front of 300 people.
The new machine in Jülich gives us the opportunity to train the largest possible AI models, and it's high time that Europe comes to terms to have their own models. We will see next year a training of a very big language model created in Europe.
We on Jupyter have simulated an ideal quantum computer, a universal one, a gate-based, and we have set a world record. So we have simulated a machine with 50 qubits, which is quite a lot. Our previous record was only 48 qubits. And then it's good to mention, if we want to have now 51 qubits, then we need a machine which is almost twice as big as Jupyter. So it's really impressive.
I'm very pleased to see so much activity on quantum and being able to see and discuss science and what's going to happen next in quantum computing technologies.
Nature is quantum by nature, so anything that you want to go at the very atomic level and figuring out how the universe works and whatnot, you need to consider quantum mechanics, right? So if you want to solve those problems at the most fundamental level, the best machines for that are going to be quantum machines. So, but they need to work at this broader context of the HPC infrastructure.
It's quite possible that the acceleration we're going to see from quantum computing is going to make a lot of problems tractable that before were very difficult to solve.
I'm really excited about quantum computing applied to material science, figuring out how to discover materials that are stronger, lighter, more efficient, etc.
Quantum is going to allow us to speed up so many of these computations, especially for drug discovery.
So it is a hybrid world. So it's not quantum, it's not AI live on their islands. It's all integrated together. And so you need that infrastructure of systems that do classical computing, AI, and quantum all together in a hybrid model.
I'm very interested to see where the next couple of years grow, because what isn't possible today may be possible tomorrow. So I'm very interested to see where it goes.
Is this going to make us better people to each other? I think we will get better answers to several things, but in the end, are we getting better as humans? I think that's quite a tricky question.
What electricity did for us a while back, computing is doing for us now. I think that we'll see a completely different future because the people that are here today will make it. And it's the biggest hope that I have, is to see the world that all these people build.
I feel like I came into this thinking I didn't know anything and realizing that everyone's in the same boat. And there's always something that you can contribute. I feel like I was worried that I had nothing to offer, and there's so many people that just in small conversations have made me feel like I'm on the right path.